Picture this. You are floating in the absolute quiet of deep space,
Oh, just total silence.
right? Total silence. You look at your window, and instead of a sunrise, you are watching an Earth set.
Wow.
Yeah. There is this soft, brilliant blue arc just slowly fading, slipping behind a completely silent, heavily cratered lunar horizon.
It is the kind of image that completely redefines our sense of scale, honestly. A visual that almost breaks the brain, right?
Yeah.
Because it forces you to process planetary motion from a vantage point totally outside of our own world.
Exactly. And that view isn't sci-fi. It was the actual morning view for 4 human beings on NASA's Artemis II mission.
It's just incredible.
Welcome to today's deep dive. This one is tailored specifically for you, especially if you want to cut through the noise and experience those real, aha moments of space exploration.
We are pulling straight from a single source today, the raw audio and detailed mission control highlight transcript from NASA Johnson.
Right. No spin, no generic summaries, just the awe-inspiring, the highly technical, and the profoundly human moments from Artemis II Flight Day 7. Okay, let's unpack this, starting with the sheer scale of what this crew woke up to.
Yeah, let's get into it.
So it is mission elapsed time, 5 days, roughly 17 hours. The crew wakes up aboard their spacecraft, which is named Integrity, and Mission Control shares these downlinked images from a lunar flyby that happened while the crew was sleeping.
And one event in those images really stands out.
Oh yeah, the moon completely eclipsing the sun. But this wasn't your normal eclipse. Because of where the spacecraft was positioned, the moon blocked the sun for nearly 54 minutes of totality.
54 minutes.
Yeah. When we have a total solar eclipse here on Earth, you are considered incredibly lucky to get 3 or 4 minutes of darkness.
Right. What's fascinating here is the orbital mechanics that allow for a 54-minute totality.
How does that even work?
Well, when you experience a solar eclipse on Earth, the event is fleeting primarily because the Earth is rotating on its axis, right?
Right.
At roughly 1,000 miles per hour at the equator.
Which is pretty fast.
Exactly. So it's actively spinning you out of the moon's shadow. But out there, the Integrity spacecraft is flying in a specific trajectory relative to the moon.
Ah,
Yeah, so instead of a rapidly rotating planet surface, you have a spacecraft syncing its orbital velocity with the physical shadow cast by the moon.
that makes sense.
They are essentially flying along with the darkness, which stretches that window of totality from a few fleeting minutes to nearly an hour.
That extended window gave them just an unprecedented look at the sun's outer atmosphere. I mean, on Earth, our atmosphere scatters light, throwing a blue haze over everything.
Which makes it incredibly difficult to observe the sun's corona.
Right, but in the total vacuum of deep space, with the moon acting as this perfect, massive, solid rock shield, the crew could see the sun's corona flowing, forming this massive, glowing halo around the pitch-black lunar disk.
And the scientific value of observing the corona without atmospheric interference, I mean, it cannot be overstated. You are seeing solar dynamics in pristine condition.
Wow.
But the sun wasn't the only light source altering their environment. The crew also documented this phenomenon illuminating the moon's surface along its edge. A faint glow they called earthshine.
Earthshine. I love that term. To help you visualize this, imagine the Earth not as a planet, but as this massive blue marbled cosmic nightlight, softly illuminating a completely pitch-dark room.
That is a great way to put it.
It is literally sunlight bouncing off the oceans and clouds of Earth, traveling all the way through the void and softly lighting up the dark side of the moon.
Planetary reflection is a really powerful force, but, that earthshine wasn't just a pretty visual for the crew to enjoy.
No, it actually caused some issues, right?
Yeah, it entirely disrupted how the astronauts perceived the lunar surface. It actually forced them to call down to the science team just to figure out what was happening to their vision.
And that post-flyby science conference is where the physics of human perception in space really takes center stage.
Oh, absolutely.
Astronauts Victor Glover and Christina Koch were trying to explain to the ground team how the sheer brightness of the Earth completely altered the appearance of the moon.
Right.
Victor had this incredibly vivid comparison. He said the difference between the dull gray of the moon and the brightness of the Earth was like the difference between an LED display and a painting.
Which is just so perfectly stated. It really comes down to emitted light versus reflected light.
Right.
You can achieve levels of luminosity and contrast with an LED display, which is emitting photons directly into your eyes that you simply cannot replicate with light reflecting off pigment on a canvas.
So the Earth is the LED in this scenario.
Exactly. The Earth, being highly reflective with its water and white clouds, acts almost like an emitter in the dark vacuum of space. It was so overwhelmingly bright that it washed out all the subtle albedo differences on the moon.
Let's define albedo for a second, just because the crew focused heavily on it in the transcript. It is essentially the measure of how much light a surface reflects.
Mm-hmm.
Christina Koch echoed Victor's observation with this beautifully poetic description. She said that before Earth came into view, the moon was clearly reflecting sunlight, just showing texture.
Right, you could see the details.
But the absolute second Earth entered the window frame, the moon dulled. It went completely matte. She called it a sponge of light.
A sponge of light is a perfect descriptor for what happens to the human eye's dynamic range out there.
How so?
Well, in a vacuum, there is no ambient light scattering around to soften shadows. Shadows in space are absolute pitch black.
Wow.
So the angle of incidence, the exact angle at which the sun's light hits the lunar dust relative to the observer, dictates everything. If the angle highlights the craters, you see texture.
Okay, I'm following.
But when a secondary, overwhelming light source like the Earth enters your field of view, your pupils constrict. The delicate, subtle contrasts created by the sun's angle on that gray lunar dust just vanish.
Oh, I see.
Yeah, the moon absorbs the glare and just flattens out visually.
Wait, I have to stop you there, because this raises a pretty fundamental question about modern space exploration.
Oh, sure. What is it?
Well, we have 4K cameras mounted on autonomous probes, right? We have rovers crawling across extraterrestrial surfaces with advanced spectroscopic sensors.
We do, yeah.
So why does NASA even care what a human eyeball sees through a thick glass window? Doesn't this prove that digital cameras are just objectively better at measuring light and shadow than an astronaut whose pupils are just, constantly adjusting to glare?
That is a completely fair point, but it raises an important distinction between data collection and data synthesis.
Okay, unpack that for me.
A digital sensor absolutely captures superior, mathematically precise pixel data. But an algorithm only knows how to record the light hitting its lens. It does not know how to dynamically contextualize anomalies.
Ah, I see what you mean.
In fact, the science team on the ground explicitly thanked the crew for their real-time verbal breakdown. They noted that hearing the crew discuss things with each other, taking raw observation, turning it into inference, and then forming a hypothesis right there in the moment added immense scientific value.
Because a camera records the pixels, but a human mind contextualizes them in three-dimensional space.
Exactly.
You definitely see that synthesis in action when they discuss specific lunar features during the conference. The crew noticed the ejecta blanket, the scattered debris thrown out by a meteor impact around M crater.
Yes.
And they observed a feature in the Oriental crater that they described as a, quote, primary ray of bone at the 3 o'clock position on the mare. You do not get a description like a primary ray of bone from an automated sensor. You get that from a human being actively translating a completely alien geological formation into a concept the team back on Earth can instantly visualize.
Furthermore, they engaged in real-time, multi-perspective peer review.
Oh, yeah.
Astronauts Jeremy Hansen and Reed Wiseman observed M crater from one angle earlier in the flyby, and then Christina and Victor observed it later.
Right, they had different vantage points.
Exactly. Because they could talk to each other, they confirmed that while the Oriental crater drastically changed appearance as their angle shifted, M crater's ejecta blanket, specifically a brownish-gray darker area, remained visually constant.
Wow.
A camera probe takes months of data processing by ground teams to confirm what those 4 humans synthesized in a 10-minute conversation.
That is fascinating. That constant comparison of stark contrasts, the brilliant, fragile Earth against the vast, dull blackness of space, prompted a pretty profound emotional shift for the crew.
It really did.
Which led directly into a historic moment, a literal ship-to-ship call across the void. Orion, sitting over 200,000 miles away, dialed up the International Space Station orbiting right here in low Earth orbit.
The timing of that connection is just remarkable, too. The ISS had just surpassed 25 years of continuous human presence in space.
25 years.
Yeah, so you have 2 highly advanced human outposts communicating across an ocean of absolute nothingness.
The camaraderie in the raw audio is infectious, by the way. Astronauts on both ships were joking around. On the ISS, they were talking about floating to the far end of the station modules to claim the record for being the absolute furthest away from the Artemis crew.
And the Artemis crew admitted they were pulling the exact same shenanigans inside Integrity.
It's hilarious.
If we connect this to the bigger picture, that lighthearted joking actually masks the immense psychological weight of what they are doing.
Oh, for sure.
Communicating across hundreds of thousands of miles of vacuum perfectly captures the dual nature of spaceflight. On one hand, you have this extreme, terrifying isolation, entirely dependent on machines to keep your blood boiling.
Right.
On the other hand, you have the ultimate representation of human unity. It takes a massive, collaborative, global effort to engineer a moment where two humans can joke with each other from different orbits.
Here's where it gets really interesting, though. During that call, the ISS crew asked the Artemis crew how looking at the Earth from the distance of the moon changes their perspective.
Oh, yeah.
Victor Glover's answer just stops you in your tracks. He said he didn't just notice the beauty of the Earth. He found himself noticing the sheer volume of blackness surrounding it.
The void itself becomes a physical presence.
Yes. He says that seeing that impenetrable blackness is what made the Earth stand out. It emphasized how alike we all are. He pointed out to the ISS crew that the exact same thing keeps every single person on planet Earth alive. We all evolved on this one shared fragile biosphere, completely surrounded by an environment that is actively hostile to life.
It is a profound paradox. The intuitive thought is that leaving your home planet would make you feel disconnected from the people on it.
You'd think so, yeah.
But moving further away, surrounding yourself with the cold, silent reality of deep space, is what finally brings the fragility of our shared humanity into undeniable focus. The further you go into the dark, the more you appreciate the cosmic nightlight.
Grounding that philosophical awe requires immense, highly technical precision, though. I mean, awe doesn't navigate a spacecraft.
No, it certainly doesn't.
At the end of the day, they are hurtling through a deadly vacuum, and they have to mathematically thread the needle to get home.
Which brings us to the physics of orbital navigation. To get home safely, the crew had to execute what is known as the RTC-1 burn, or Return Trajectory Correction 1.
Right. The ground team confirms they are go for this tiny maneuver using the reaction control system thrusters on the service module. It's designed to fine-tune their path back home right after they exit the lunar sphere of influence.
And for those listening, that is the threshold where the moon's gravity is no longer the dominant force pulling on the spacecraft.
The precision required for this burn is staggering. The transcript shows the burn created a delta V, which simply means a change in velocity of just 1.6 feet per second.
Barely anything.
Right. To put that in human terms, 1.6 feet per second is barely a slow walking pace.
It's incredibly subtle.
To really wrap your head around how wild that is, imagine you were standing on a frictionless ice rink that is 200,000 miles long.
Okay.
You slide a hockey puck toward a goal on the far side. Halfway across the rink, you lean down and blow on the puck gently through a straw.
Wow, okay.
That tiny puff of air is the 1.6 feet per second burn. It barely changes the speed of the puck at all. But over the next 100,000 miles, the geometry of that tiny angular shift multiplies.
Right, the compounding effect.
Exactly. That single puff of air determines whether the puck perfectly hits the center of the net or completely misses the entire arena.
That is an excellent way to conceptualize vector mathematics in a vacuum. A fraction of a foot per second dictated whether the Integrity spacecraft would safely hit the narrow corridor of Earth's atmosphere for re-entry or just skip off the atmosphere and be lost to solar orbit.
It's terrifying when you think about it.
And that delicate mechanical balance extends inward, too, to the physical realities of simply living aboard the ship.
The wiggling.
Yes, the wiggling.
This was one of the most surprising details from the mission. We learned from the transcript that simply doing a daily workout has serious structural implications for the spacecraft.
Right.
Victor Glover starts exercising, and Reed Wiseman calls down to Mission Control to report that they can physically feel the vehicle moving around. He specifically notes it's not like a ship rocking on ocean waves, but a distinct wiggling sensation through the hull.
What they are experiencing there is structural resonance and Newton's third law in action. Every action has an equal and opposite reaction.
Right, classic physics.
On Earth, if you run on a treadmill, the floor absorbs the kinetic energy, and the massive foundation of the building dampens it.
Sure.
But in the vacuum of space, if an astronaut pushes against a resistance machine, the mass of the spacecraft has to absorb that force.
Because there's nowhere else for it to go.
Exactly. Without gravity, air resistance, or friction to dampen the kinetic wave, the energy travels through the metallic structure of the ship. The entire vehicle literally wiggles.
And Mission Control cannot just ignore that. They actually command the ship to park the exterior solar arrays into what they call a safe harbor position.
Yeah, they have to.
They have to geometrically lock down the massive solar panels so that the structural wiggling from an astronaut doing squats doesn't cause the panels to flap like bird wings and snap off.
Which would be catastrophic.
Right, you have this incredible mix of mundane daily exercise requiring life-threatening structural mitigation.
It highlights a critical reality of spaceflight. You cannot just exist in space. You have to actively manage your existence every single second.
Absolutely.
Every variable, down to the kinetic force of a human footstep, must be accounted for. Yet, even amidst that intense technical management and survival calculus, NASA ensures there is room for human history and legacy.
Oh, the artifacts.
Yeah.
The official flight kit aboard Orion carried some incredibly heavy historical artifacts. They packed flags from the very first space shuttle flight, STS-1, the very last shuttle flight, STS-135, and the SpaceX DM-2 mission, which brought orbital launches back to American soil.
But the artifact carrying the most historical weight is the Apollo 18 flag.
That flag sat for 50 years. It was originally supposed to be planted on the lunar surface during Apollo 18.
Which obviously never happened.
Right. When that mission was canceled, the flag was placed on display in the NASA headquarters building in Washington, D.C., where it sat untouched for over half a century. And now, it finally made its way around the moon.
It is the physical representation of a delayed promise, a continuation of a journey that was paused for decades. And the Artemis II crew is acutely aware of that legacy.
They definitely are.
They actively sought to capture the universe to share with the rest of us. They requested mission control to temporarily disable the solar array cameras just so they could take deep sky, long exposure photographs out the windows without the glare from the equipment ruining the shot.
They wanted to make sure they got it right.
They wanted to ensure the legacy of the mission was documented perfectly.
So what does this all mean? We have explored everything from the orbital mechanics of a 54-minute eclipse to vector adjustments of 1.6 feet per second.
A lot of ground covered today.
Definitely. And for you listening right now, the chances are you won't be navigating a spacecraft through a vacuum today.
Probably not.
But consider Victor Glover's perspective. Think about the difference between the LED display and the painting. Sometimes, taking a deep space perspective on your own daily life, recognizing the contrast between the glaring, overwhelming noise, the LED, and the subtle, nuanced details, the painting can completely change how you view your world.
It's so true.
It is about recognizing the shared fragility of the people around you, living on the exact same cosmic nightlight.
And if you want one final, fascinating thought to carry with you today, consider a quiet detail from the science conference. Before the call ended, the ground team officially confirmed to the crew the specific coordinates of the proposed Integrity and Carroll craters.
Craters physically named by this specific mission.
Precisely. Even before humanity sets foot back on the lunar dust, these 4 astronauts, communicating over hundreds of thousands of miles of void, are already reshaping the map of the moon. They are leaving a conceptual footprint of their journey for future generations of explorers to navigate by. The map of the cosmos is being actively rewritten.
Naming the cosmos before we even touch it. Think about that the next time you look up at the moon. Keep exploring.